Spheres of equal radius r moving there. Two spheres of move horizontally in opposite directions. First has a mass of 2m and a speed 2u. The second has a mass m and a speed of 4u. The coefficient of restitution is 1 over root 3. The centres of two spheres lie on parallel lines distance r apart. Show that the moment of impact the line of centres of spheres makes an angle of 30 degrees. Okay, so what I'm going to say is something like this. If you imagine that these two spheres, I'm just going to draw a square apparently. So there's one sphere, there's the other sphere there. Now, guys, what I'm going to do is I'm going to move them along this axis here, and then they're going to collide into each other like so. So they're going to roughly impart this way here. Now what we're next going to do is we're going to put a centre of the circle of each one. Okay. Now, can anybody tell me what's the distance between the two centres in terms of r? 2r. And then if I go directly up, r. So we have a triangle of 2r and r. Then I'm going to find out this angle of impact. Okay. So what we'll do is we have the opposite and the hypotenuse correct. So sine theta ends up to be r over 2r. Sine theta ends up to be a half. Sine inverse a half. And once when you sine inverse a half, what are we looking to get? 30 degrees. Theta is therefore 30 degrees. Everybody cool with that? Any questions? What we're going to do next, lads, is we're going to I'm going to draw this line here. Now I get to do a fancy little trick because of what I have going on here, but you guys will obviously have to draw this yourselves. So what I'm going to do is I'm going to link them together, and you can obviously see that that's my my 30 degrees is in here, yeah. Now we've never answered a question like this before. We always answer like the two parallels in the same line as each other. Okay. So what we're going to do is a bit of a magic trick. We're just simply going to rotate it like so, and now all of a sudden they're both traveling in the same direction. Okay. Oh, sorry, they're both on the same level, and we can analyze the new velocities just by tilting them up 30 degrees. Okay. So what we're going to do first is we're going to look at, we might label them. Is there names for each one? Not really, we'll just call them A and B. Okay, so sphere A, as we can see, is going up by 2u, isn't it? In the diagonal. We know that's 30 degrees. 30 degrees up. So that's going to be 2u cos 30 and 2u sin 30. Well, somebody tell me what 2 cos 30 is. What's cos 30? Is it half or root 3 over 2? It's root 3 over 2 actually. So it's going to be root 3u. And the other one's going to be 2 times a half u. So let me just make sure cos 30 is root 3 over 2 for a second. Is it? Yeah. Good. Okay. So that's that one broken up into what we need to know. Now, the next one is next one after that. We got to break up the speed of B. So the speed of B is going to be, it's going diagonal left down. I'll do it in red here, and not that be cute. I won't. Okay, so we'll just do it here actually. Okay, it's going downwards like so, and we'll take its speed. So it's 4u. Going this way, it's 30 degrees, so it's just going to be double the last one, isn't it? Except in the opposite direction. So it's going to be 4u cos 30 and 4u sin 30, and we know it's double the last one, so it's going to be 2 root 3u, and the other one's going to be 2u. Okay, now we've gotten our before picture sorted now, yeah? So for that. So 2 root 3u. Okay. Now, Find the speeds of the spheres after impact. So what is our two equations we just always write down at the start? PCM being the principle of conservation of momentum, m1u1 plus m2u2 equals m1v1 plus m2v2. Your second one being NEL, Newton's experimental law, being I always get this one mixed up. Yeah, it's u1 minus u2 equals minus E into V1 minus V2, and you of course can turn that into V1 minus V2 here, and then just bring it down. Oh, that's not rubber. And there you go. Okay, so there's your two equations there. Time to work with them, okay? So make yourself a list. Now, in questions like this, it might be worth just specifying what M1 is as well. So it might be just worth making a little list here to the right. So M1 is, what's the mass of the first one? The one to the left, that is. That's 2m, and this one? M. So M1 is 2m, M2 is m. U1, anybody? We're only taking the speed along the line of centers, aren't we? So it's going to be the root 3u, and the u2 is going to be, anybody? u2? 2 root 3u, and it's actually going in the opposite direction. Technically minus 2 root 3u, but yeah, it is minus 2 root 3u because it's going left. It's going left. Okay. Now let's start off with PCM. PCM is m1, which is going to be 2m times u1, which is root 3u, and then plus m2, which is m times minus 2 root 3u. They're going to cancel each other, aren't they? The next one then is going to be 2mv1 plus mv2. Cancel all the m's. And 2 root 3u minus 2 root 3u is going to be 0. So 2v1 plus v2 equals 0. Everybody happy with that?
Isn't the v1 and v2 at the top for the equation?
No. Why is it?
v1.
Sorry guys. Newton's experimental law. Excuse me guys. I just actually had it the wrong way around. Because E has to be a fraction. E does have to be a fraction smaller than 1. So that means that the smaller number goes on top, which is the differences of the v's. Because you lose speed after the collision, and then the differences of the u's are on the bottom. My bad. Either way, it's in your tables. Get in. Okay. Now, next one. V1 minus V2 all over. What's U1 minus U2? It's root 3u minus 2 root 3u, which is going to give me minus root 3u. We know the E value, don't we? E value is 1 over root 3. So it's going to equal minus 1 over root 3 because it's minus E, this thing here. Okay. Then we're going to cross multiply V1 minus V2 equals minus 1 over root 3 multiplied by the minus root 3 that's about to appear on the bottom. Root 3u, that is. Because the 2d's here, if you take them away from each other, it will get you minus root 3u. Cross multiply, the root 3's cancel, and we're just going to have v1 minus v2 equals u. Then we're going to combine both equations together, and we're just going to add them together because they actually work out quite nicely. There. So we're going to get is 3v1 equals u, v1 equals u over 3. What's that make about v2 then? v2 equals v1 minus u. v2 therefore is u over 3 minus u. v2 is minus 2. Whoa. So basically guys, we made a mistake here because this is implying that the sphere goes directly to the right, and the second sphere is continuing to go to the left, which we know is impossible. It's like they went straight through each other. So it means we made an error somewhere, or I made an error somewhere further down. Now the error that I think I made was in here in Newton's experimental law, I actually neglected the second negative, the second number. So just going to go for this one again. One moment. What we think happened was we forgot that it's minus 2 over 3u. So what we're suspecting is it's phi1 minus phi2 all over root 3u minus 2 over 3u. That's where the mistake was made, equals minus 1 over root 3. Phi1 minus phi2 all over 3 root 3u equals minus 1 over root 3. Those, the minus, that can take, the root 3 can go away, and then we have phi1 minus phi2 equals minus 3u. Is that right? I think we're good now. Now that I have that done, what we're going to do next is, guys, we're going to put this up here, and now we're going to do the same thing again for phi1, phi2. Now, phi1, phi2 is going to be 3v1 equals minus 3u. Phi1 is equal to minus u. Therefore, phi1 minus phi2 equals minus 3u. Phi2, therefore, equals phi1 plus 3u. Phi2 equals 4u. Is that right? Now that's sort of what we'd expect, is that a heavier object collides with a lighter object, and the lighter object is coming out the opposite direction much faster than the heavier object is. That generally happens a lot. Okay? Now, what does it specifically ask us for? Does it specifically ask us for the speed, or does it specifically ask us for... Sorry guys. Here is actually phi1 was actually minus u, which makes that 2u. Excuse me, phi2 is actually 2u. Excuse me. Now, what we have here is we go back to the top, and what do we know about after? What do we know happens? Find the speeds of the spheres after impact. What do we know about during the collision? The y values are never affected, right? So those values are never affected. So we're going to draw a before and after picture again. So this is the after picture. We know that phi1 is going to the left. So it's going to go to the left and downwards. Oh, sorry, left and upwards, excuse me. Left and up. So, what we have here, guys, is two components. The first component being your v1, which is minus u, and your j component that never changed. What's the speed of that then? Using Pythagoras' theorem, we'll call it let's just call it x. X squared equals u squared plus minus u squared. X squared equals 2u squared. X equals root 2 u. That's the speed of the first particle after collision. And then once we've done that, we're going for the other particle. It's going to the right at a speed of 2u, which is this here. And what was its old velocity? Its old velocity was going down at 2u, wasn't it? So it's now going to the right and downwards. So change this for a second. So that's 2u is the x component, going this way here, and the y component is also 2u. So what we're going to do here is we're going to square both of them and add them together. So we're going to get 2u to be squared plus 2u to be squared equals y. So y squared equals 2u to be squared plus 2u to be squared. Y squared equals 8u squared. Y equals 2 root 2 u. Root 8 is 2 root 2. Okay, so that's our two speeds there.